Okay, today we are going to study about matrices and its operation. So yes, we have some objectives of today. These are the objectives. We will first of all create a matrix using compile time, not compiler time here. How to create a console input in R programming, because we also are going to study about that how can I create a matrix using runtime console input. So this is the thing. There will be, we will discuss two methods to create a matrix. So first of all, we will use here for loop, and another which we will use an abstract data type that is called scan. And then we will discover some or do some experiment about matrix using indices, and also then we will use here negative indices experiments, and thereafter we will try to use some different methods related with matrix, such as these methods we will going to study n row, n column, dimension, length of the vector. Okay, so this is very important to begin with R and also matrix, which helps us to manipulate data. So let us begin with some simple definition. So as we know that, so let us see is the recording is started or not. Yes, I think it is started. Okay, so first of all, I'm not starting from the beginning of the R. Okay, the introductory part of the R. This is what we can say that after learning the basic syntax of R, we can start with matrix. Okay, so first of all, we have to study the vector. Okay, so vector is a collection of homogeneous data, and if I want to say in simple terms, vector is created by using this this syntax. So it will contain some elements of the same time. Again, there is multiple characteristics of this vector, so it will contain elements of the same type. Okay, so here I am just adding here strings only, so that's why it is a vector of strings. Okay, an array is an extension of vector. Okay, more than one vector, or we can say, so array is a collection of vector, and matrix is an extension of array. So but in case of R programming language, unlike other programming language, R doesn't have multi-dimensional matrices. So matrix is a two-dimensional array in case of R. So that means R will only have two dimensions of matrices. Okay, so to be a matrix in R, it must have two dimensions. That is the number one characteristics of matrix. Number two characteristics of matrix is we can access elements of the matrix using some indices. We can access elements iteratively also, and also we can perform different operations on matrix, different operation. Again, we can form different kinds of matrix, for example diagonal matrix, sparse matrix. So there is lots of experiment we can do in matrix. And why matrix are important? Because in the real world most of the things are stored in two dimension. Okay, but yes, we have tensor quantity also. Okay, tensor data also, but matrix is the fundamental way to learn about those tensor quantities, we can say. Okay, so let us begin with creating matrix in compile time. Okay, so there are different methods, okay, we can use to compile matrix, but the basic idea of creating matrix is simple. So let's say I am going to create a matrix. I will say it is a matrix 1, and let's look at the syntax. Okay, so we have created a matrix. So look at the parameters of it. Okay, that is very important for us. First parameter is a vector. So every matrix we should insert a vector as a parameter in the first position. Next parameter is the number of rows, and in basically in competitive examination one may ask, okay, what will be the second parameter and what will be the second what is the meaning of the second parameter also. Okay, n coulomb is also the third parameter, and the most interesting thing is the by row parameter. So by row parameter, when I set this by row parameter as true, that means it will insert all the vector elements row measure order. Okay, so that means row measure order means it will preference the rows first, then it will move to the column. Okay, so first of all it will fill one row, then it will fill another row. So that is the way, or we can say that is the meaning of row measure order. And this sequence method basically it does it actually creates a vector from one which contains some contains numeric data. This is not integer in case of R. Integer is different in case of R, but this is called numeric. It belongs to a class that is called numeric from 1 to 10, and this is the step count. In Python also we have the step count. We can use the step count, but here I have set this step count is equal to 1, and it will create a vector 1 to 10. So let us see how the things are being done. Okay, so as you can see, the first row contains 5 elements. Okay, since we have selected these 5, so it will insert like 1 2 3 4 5 by following the row measure order, and the second element or second row also get filled. But what if I want to do some experiment here? What if I do this? Okay, let's see. Okay, because if now I want to store 8 elements, okay, but I have a matrix of 10 elements, so what will be there? Okay, yes, we have an issue. Okay, we have a warning, but R adjust by itself. Okay, so what R did, R reduced the size of the matrix by itself, by its own. So we can see now coulombs are, number of coulombs is 4. Okay, and the size of the row become the standard size. Okay, this is very interesting to see. Yeah, but let's see what if I insert here a minor negative number. Okay, that will be also interesting to see. Let's say if I do this, what will happen? No more error handlers available, invoking about it. So it didn't done anything exactly, and also there is an error appear. So that means it appears an error. So this output is from the previous console output. Okay, so this is the error basically. So that means coulomb number always should be a positive number, but this coulomb number can be, one may write this coulomb number not following this factor, but the problem will be that all the elements will not be printed in this console output, and also it will print us an error. Okay, that is basic thing. But what if I do not write here anything, if I do not write any value here? So let's see what will happen here. Okay, so yes, that's really interesting output. So as we can see, by default it have created automatically 5 row, 5 coulombs. Okay, 5 coulombs it have automatically created. that is very interesting thing we can see here. Okay, now let us do another experiment. So I will keep, this is a 5. Okay, now what if I do this 1? Will it print? Yes, yes, it will print definitely 1 row and 5 columns. But what if I do not print any row here? Will it print any column here? I want to see, since when I don't give the argument column, it automatically created 5 number of coulombs. I think the it is running an algorithm behind it. So the R found that there are 10 elements, and I have to equally divide the 10 elements into 2 rows. So 2 divided by 5 is equal to 10 divided by 2, 10 by 2 is equal to 5. So that means 5 elements should be in the coulombs. Yeah. So let's see if I do not add here any argument for the row. So let's see what will happen. Yes, now also we can see the row is automatically get identified by the R. So we can clearly see that the number of column, I think the sequence, there is a 10 number of elements in there, and behind us is seen R is calculating that how many rows there may be. So definitely the 10 by 5 is equal to 2 number of rows will be, it is finding implicitly. Okay, implicitly. So this is very interesting. But what if I do this? Okay, what if I do I said this R rows equal to, okay, this not rows, this is n row, n row is equal to 0. So what if the output? So I said that there is no, okay, it is an error. Oh no, it is not an error, it is a warning. So that means I cannot, now there is no implicit output, okay, from R, because we as a developer, no, we are not currently developing, but we as a programmer, we have explicitly expressing that the value of the R should be 0. So that's why R is not taking any implicit value for the console. Okay, so that's why we can see here this is just the number of coulombs. Okay, this is the number of coulombs, not the coulombs. The index of the coulomb, other way we can say. And if I do this also, let's see what will happen. There is no output, and also the output is something like angular bracket 0 by 0 matrix. This is very interesting thing, and this kind of question may ask in different examinations. Okay, so let us check our original matrix, because I also want to see that how it, if I do this. Okay, so that's really, that will be also great to see. Okay, so if I do this false, so now it will follow the coulomb measure order. So that's why 1 2 3 4 5 6 appearing like coulomb wise. Okay, and this is how I can create a matrix using compile time. But again, we have used here a sequence. Can you use here let's say, so what if I do not add there any vector? Okay, if I make this empty, so what will be the output here? This will be again really amazing to see. So let's create another cell. So I will see there how to do it. Yeah. Okay, let's see. This will be matrix 2 and matrix 2 matrix. Okay, I will keep it null. N row. So I will keep it 2, and column will be also, I will keep it 5 by row. I just want to keep as it is. Okay, then matrix 2. Okay, so let's see, is there any error, warning, or other things? Okay. So it is better to use this arrow, okay, not this left head arrow sign when actually we are not using any function. Inside this function, it is a good practice to use this equal, but the meaning of this two symbol is same in case of R, but this is a developer language, okay, because when I write this equal, so the other developer also may know that okay, he is using function there, okay, just looking at this sign. So this is a communication that how developers enables in between them, okay, throughout the globe, okay. So the next thing, I have not added here any by row, this is I have not added there any vector here, so I think that may be an error, but I have written there a comma, so to specify that there is no thing. So let's see, yes, we get an output, but all the output containing are not available. So not available is also a specific class that is defined for R. So what I can say, so when no vector is passed, the matrix elements will be not available, okay. So this is again a very interesting experiment we have done. Now let us create other ways to create a matrix 3, okay. So if I let's say if I do here data is equal to, let's say 5, okay, n row, and I will make it same. So I will just copy here and paste this thing because it is taking too much time. So okay, what I will do here, data is equal to 5, okay, and let's make it matrix 3. Yeah, let's run it. Okay, now a constant element is being printed all over these cells, or we can say element position. And what if I do not write their data? I think this must be also the same 5 or same output should be there. Yes, definitely. So it doesn't matter that you should write here data is equal to this, data is equal to that, okay, it doesn't matter. And I think same goes for this also. Let's do experiment. If I do this, what will be the output? I think this is the same, okay. So you can write the exact attribute here, so it's much like a dictionary kind of thing. So or it's like a named vector, but it is a matrix, okay. So there are different types of vector also. So named vector like this, okay, similar to this, but it is not mandatory to write the corresponding name for that position or positional argument, okay. Now we have to create let's say okay, I forgot what I have to discuss again. So let's create a cell first. So I think I have written here, yes, this is also a way to create a character matrix including some character, okay. So I will do this data is equal to, so what I will do, there is a built-in attribute that is called letters in I think letters in R programming language, and which contains all the alphabets from A to Z. So I will, let's say 8, okay. So then in that case I will say that n row, that is 2, and n column, that is 4. So 2 4s are 8 will be there, and by row, yeah, by row is equal to, yeah. So let's print this matrix 4 and let's see what will happen. So have I written it okay correctly, by row is equal to 2, okay. Let's see what happened. Okay, there is an error. Then let's see why this error happened. I think this must be letters, probably. Yes, this must be letters. yes, I have a typo. Okay, I had a typo, that is I had written there letter, but it should be letters. So what I have did, I am printing the letter, okay, alphabetically from 1 to 8. Okay, from 1, that means from 1 means A and 8 means 8. So this is how I can do. Again, there is a question coming to my mind. Can I print these letters from H to A? Is it possible? Is this possible? I just want to check. If I do this, so let's say what will happen here. Yes, this is also possible. So if I print in the reverse order, it is also possible, and that's a great thing. Okay, in case of matrix. And finally, we have done much for this compile time matrix creation. Now we will move towards the runtime matrix creation. That means we will give the input in the runtime. So how to create a console input in R? So that means to take input in the console, okay, in the runtime of a program. How can I do it? Okay, so there is a method that is called readline, and that method we basically use to take input from the console to our program. Okay, because our program will directly interact to the operating system console. Okay, so whatever input written by this program or by the interpreter, so that will go to the console. Okay, and console will again interact to the cell, and then different kinds of things will be happen to the operating system. So that is not, I'm going not far to the system level operation or system I think system architecture. Okay, so we are not going to study that. So the main thing in this case that we are going to take any input from the console. So let's say we have to use a method that is called readline, and this readline method, there is a I think prompt, okay, prompt argument, and you can write your prompt, enter a number, okay, and you can print this number like this. This is basic thing. Okay, so this concept we will use to create a matrix. Okay, enter a number. Okay, we have did it. Read line. Yeah, that's correct. That's correct. Is there any error? Okay, it should ask us. Okay. It is asking us. Okay, here the console is the below. Okay, this is the console. So we have to print here. We have to give input exactly, and the print. We can see it is printing 5 here, but also we can see this R markdown file also. Yep, this is the markdown file that I have created. You can see the extension here, RMD. So this is the output we have got. So look at this thing, that this output, this is the output. It is not an integer or numeric type. Okay, so be careful that when we are and when you want our input as I think integer or a numeric, we have to convert it. We have to typecast it like other programming languages. Okay, so yeah, so we will do that in when we are in this program, that we are when I create the matrix in runtime. Okay, so now the main thing is here. So we are going to create a matrix in the runtime. Okay, so all the matrix have some have a row or column. So first of all, we will define this row. Okay, and now this size of this matrix I will also take in runtime. So first of all, we will convert this to an integer. So as I can convert into integer, I can convert to numeric, but if it is numeric, definitely it will be also but by the system level, it will in the system level it will be double. Okay, so it is better to convert it into integer, and then I will write this readline method, and inside this readline method I will add here the prompt, prompt equal to, so enter the row size. Yes, that is it. closed. Yeah, this is correct. And the same and I will use the same for the coulomb. Okay, so now enter the coulomb size. Yes, this is good. So now we have row and coulomb. Okay, so but when I use this readline method, we can see that the readline only takes one input at a time. It will not take multiple inputs at a time. Okay, so in this case we have to use for loop. So that's why we have said that it will increase the complexity, because since we are using the for loop, it will iterate over n number of times. So where n is the size of the matrix. So for this we also have to create a vector, and we whatever we are getting from this getting input from the console iteratively using the for loop, that all I have to push it to an empty vector. So how can I create an empty vector? So let's create a vector. Okay, there is a numeric method. Okay, numeric method, and this numeric method, what I will do, I will store the exact number of elements what I want for the matrix. Okay, this is a vector. Again, it will store a collection of elements. Okay, that means it will contain those elements are 0. Okay, so what I have to do, I have not executed this statement, so that's why it is not printing. So now I can see, I think let's see. Okay, I also forgot this. So we have to do one thing, we have to write the size. So first of all we have to write this row size 2 and coulomb size 3. Okay, it is again asking me for coulomb size. So why it is asking me? So now we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. So why it is asking me why we will get 3 number of, I think, elements here, because since we have the console asked for 3 times coulomb 3 times, and that's why I think we have got here 9 number of elements. But we have to check, okay, why the console asking for 2 times for the coulomb input. Okay, let's see. Again we are going to run this thing, because coulomb should be asked only one time. Okay, so this is 2. Okay, enter the coulomb size 3. Yes, now it is correct, because maybe there may be some iterative since I have used here sequential execution. I have done the sequential execution by explicitly pressing the control enter. So that may be the reason. So the coulomb may take the 2 times input 2 times. So that's why the size of this vector become 9 also. Okay, and now you can see that there is only 6 number of elements in this vector, and this is an empty vector. So what we are going to do now, so we are going to do create a for loop for I. It's like Python syntax. Okay, for I in. Now the most important part is this case. So I am going to check the length of this vector. Okay, so this coulomb means that I have to check it for from 1, okay, from first element to the size of the length of this vector. I do not let's say I do not know the vector's length, so I will do this then. Okay, so now what I will do, I will store this, I will reinsert the elements in this vector. Okay, this is the position 1 of this vector, and here I will use readline method again, readline. Okay, so readline prompt Okay, prompt equal, I can do one thing. Okay, let's use this paste method. This paste method actually helps us to concatenate things. Okay, let's say I will write here insert element element, okay, I. So this is what we want here. Okay, but again we have to convert it to integer, so that's why we will do this as integer. So whatever we are taking from this read line, this console, I will convert back into integer. This paste method is just used for concatenation, and this insert element and this I. So factor I will contain the iteratively all the console inputs. Okay, so let's see it will work or not. So let's see. Okay, it should work, but again I will complete this program. Okay, first of all, so now I have the vector. Suppose I have the vector, and then what I have to do, I have to create the matrix. So let's say matrix is my matrix, and this my matrix is I will create using this matrix method, and I will insert the first parameter, which is my vector, and how many okay, size, definitely it is like n row is equal to row, and n column is equal to column, and then by row is equal to, I will make it row. Okay, and then print this, we can direct and print this like matrix. This is good. So I hope it is true, but let's run, then I can see is there any problem or not. So yes, again I will try to insert this 2 and column size. Okay, so I think I have got an error here. Okay, then again we have to check from, okay, so it is saying that this function doesn't exist. I think this is the wrong, again I have made some typo. Okay, I have made this typo. Okay, so then again we will check this, and column size. Okay, I have too many typos here. Vector p c t o r. Let's see, have I done any typo? This is also another error. So there is too many typo. Okay, there is too many typos here. These typos are really bad when you are, I think, for my case, actually my brain first more than my brain's acts more than my typing skills. Okay, so let's see again what will happen. I have to remove this typo. Okay, we are getting the things. Okay, now insert element 1. So let's say I will insert 1, insert element 2, I will insert 2 here, insert element 3, I will insert 3. So if you want to see this, definitely I will make it visible. So 3, then insert 4, I'm inserting 4, 5 inserting, so this is 5, and the last element 6. Yes, we are getting the vector here, so this is the correct program. Okay, so that's good, exactly, we can say. Okay, so now what I'll do here, I will erase the all previously created objects. For our next program, what actually we will do here, so there is a problem in this case, that there is a lot of lines. Again, we have a for loop which is increasing our complexity to the, I think, order of n. Okay, so that is a problem. So what I can do, I can use abstract data type, and that is a scan method. Okay, this scan method can take multiple inputs from the console in one command. Okay, in one go, we can say. So what I will do, I will copy this, the same above matrix, and I will print this. Okay, I have to copy this and paste here. Okay, now what I will do, I will make this vector using scan. Again I have to write the, okay, this is again very important. So n max, that means the maximum number of elements that n can take, that is I will do row multiply vector, row multiply column. Okay, row multiply column, then this is the thing, and I will then truncate this for loop, and again in here the vector will be there. Yes, that's all we want here. So this is how can I do. So just I have edited this scan method. I have inserted this scan method. Instead of creating an empty vector, we have directly created the vector not using any for loop. Okay, let's see it works or not. So again it will ask us enter the row size. So I will again insert 2 here, enter the column size 3. So now I will insert the elements. Okay, so let's do it. 1 2 3 4 5 6. Yes, so as you can see, it is the same output is given, but with low time complexity, and the time complexity in for this case, I think it will be order of 1, because we do not have any iterative function, so that's why it will be order of 1, constant time complexity. So now since we have created a matrix, that is I think the size, we can see this matrix. So what I will do, I will print this matrix here again. Okay, we can see this when I do this print matrix, it is printing on my console. Okay, so it is not printing on this markdown file. So that's why it is also a disadvantage of using print when I am using this markdown file also. So what I'll do here, for better understanding, I will reprint this matrix on our markdown file. Okay, I think it is printing. Okay, in this case also, I think it will also print in this case. I'm not going to do it again. Stop this here. So this is my matrix. Okay, so we can see these are the elements. So the main thing in case of matrix in R, that the indexing starts from 1. So if I do this my matrix like 0, 0, so it will be a, I think, okay, what is it doing exactly? Oh yes, I got it. There is a problem in here. So because I have already I have run this program, so that's why I ran this program time ago. So that's why it is so the 2 cells are simultaneously running. So what we have to do, we have to do this again. Column size is equal to 5, and 1 2 3 4 5 6. Oh, okay, I forgot to add the space. Oh my god, that is a big problem. So so always try to add here 2 spaces. Okay, 3 4 5 6. Yes, so let's run this again. Okay. Okay. My matrix. Okay, let's print this my matrix. What is the output here? Okay, why it's taking lots of amount of time to print this my matrix? There may be some issue. Okay, so this matrix is also something like this. So 1 2 3 4 5 6, 10 elements is being printed into a 6. So okay, number of rows is equal to, I think 2 and 3 is there. I have inserted, and again Okay, let's do it again, because I have done something wrong in here. So again I have to do it. Okay, it is also not running. Probably I have to delete these all things, okay, from here, all objects from here. Okay, let's do it again. Okay, it is again not running. So okay, this is good. So what I will do here, okay, let's use this matrix. Okay, so I think I have to restart this RStudio. So the problem is with this RStudio. Okay, there is too many things are going on here. Let's open this again. Okay, so let's run this. Okay, as you can see, this is the output, and I will use this in my next program. Okay, I have typed that down, matrix 1, and let's see. So it is printing my matrix. Okay, that's great. Okay, so what can we say, that there is for matrix in R, so there is no zeroth element. Okay, so that means it will start from first element. So if I print this thing, my matrix 0, 1, my matrix. So again here I will write two function, that is n rows, number of rows of the my matrix, okay, and okay, and column of my matrix. Okay, this is a method. These are two methods. Okay, so n row. So let's run it first of all. If there is any error, I can say, yeah. Okay, this would be 1 and 1. And here number of rows, okay, n row thing, so let's see what are the methods in there. Okay, this is the same thing what I have written. So this n row should contain the my matrix, yes, n row x and n row. Okay, this is again a typo error is there. Yes, now as you can see, this n row is taking the length of the row, which is I think it is 2, and n column is 5, so that is the 10th element it is moving towards. Okay, second row 5th column, that is the 10th element. And as you can see that if I write here 0, it may be some numeric 0 kind of thing, so that is unexpected result will be there. Okay, and this 0 0 will not contain anything again, there is no value for 0 0. All matrix in R, in case of R, it starts from 1, but there is a case for negative index. Okay, so let's print this my matrix again, matrix, okay, in a separate cell. So then I will do this negative indexing. So run this. This is the matrix. So what if I do my matrix? What if I do my matrix as 2 minus 4? What will be the output for this case? The output is really interesting in this case. This is 2, 4, 6 and 10. So when I use this negative indexing, it will print a vector containing all of the elements, and also it will exclude that particular negative indexing, whatever it is, row or column. So here I have written here 2 and minus 4, so it will print the second row, and except minus 4th column it will print all of the columns. That is a very nice example. Okay, so let's say my matrix, matrix, my matrix. So if I do this minus 2 and minus 4, let's say, so what it will be happen in this case, it will remove this. 2 means it will print the second column, minus 2 means it will remove the second, 2 means it will remove the second, it will print the second row, and minus 2 means it will remove the second row. Okay, and minus 4 means it will remove the 4th column. So what will be the output? So this row will get removed, and for this minus 4, this column will get removed. So what will be the output? 1, 3, 5 and 9. As per my expectation, let's see. Yes, 1, 3, 5, 9 is the output. This is very amazing thing about matrix. Again, we can do lots of experiment with it, but I think we can proceed further. Okay, just do it again. This is the last. So what I will do here, I will exclude this second row. Okay, and I will just print only I will just print only this 4th column. That means it should be. So I think this is very critical to understand. So but let's see what will be the output. Okay, yes, this is very interesting. I am excluding the entire second row. It will get 8 will also get excluding. So what left? Only 7. So that's why the output is 7 here. this is very interesting. I have excluded entire second row, and then I am printing the second fourth column, okay, and the fourth column element after excluding the second row is 7. Very interesting, very interesting for negative indices. Now there are some methods related to matrices. So for example, this is the dimension method is also there. So it will give us the exact dimension for the matrix. We can see, okay, because this matrix doesn't exist, so that's why it is. So this is also a good thing, because if there is a empty matrix, so the dimension will be null. Okay, this is also a good output for us. Again, if there is a exist non-empty matrix is there, my matrix, like my matrix, so it will be the number of rows and number of columns will get printed here. Okay, and for a null for empty matrix. After this, what we have dimension, we have checked indices, or we can or also again we have checked lots of the thing. Okay, also we can convert this matrix to a vector, VCTR vector, and I am not converting it. Okay, I am not converting, just I am writing the syntax. So I think as we have to type as the basic thing as vector my matrix. We can do this. This is how we can convert a matrix to a vector. Okay, so the entire matrix will get converted to one-dimensional vector. VECTOR. Okay, that's correct, as vector. Let's see what I have to discuss again. Length of the matrix. I think we have done this length of this matrix probably. Okay, for this length, for this case I have not done. For matrix case I have done it for vectors, and I also that same thing can be done for matrix also. It will remove the total number of elements, I think. Okay, this is again interesting. So we can see that this matrix, it is a, I have not initialized any variable like this. Okay, I have not declared or initialized any variable like this, but still it is returning me 1. That is very amazing to see. Still it is returning me 1. That's really interesting point to see. Length my matrix. Okay, let's see. Okay, control enter. 10 elements. Yes, definitely it is 10 elements. Okay, this is how we can create a matrix in compile time, in runtime, and also we have seen some basic operation we can do on matrix. These are not arithmetic operation. This is how can I subset the matrix. That means subsetting means that we can access the elements of the matrix. Okay, and also we have seen the negative indices. Okay, and there are some methods that may help us in the upcoming future if we are moving towards data science and machine learning projects. Okay, so this is all about the first video of this matrix session. Hope it is all in it is very enjoying and raw kind of thing, because I really like to make raw videos and raw things. Okay, and it is also improving, it also improves my mistakes in my conversation also. So it is all right, then wait for the I think next video. Yes, goodbye.